Aloha and welcome. In this section, we're going to be talking about iterating over a list. You're going to find it very familiar. We've already done very similar things with strings. So stay tuned. We're going to open up here our code, VS Code, and we're going to take a look at this. So iterating over a list. We've done this iteration in the chapter on the for loops. So looping over a list is so common that we have this for loop just for this purpose. So in each iteration, we bind the next value in the list to the loop variable. And iterable objects are objects whose elements we can access one at a time, like lists, strings, and tuples. And we've seen examples in the past like strings. So when we do this, let's go ahead and set up a for loop to do something. Let's say we have cars equals, let's make a list. We're going to say Prius. We're going to say Odyssey, although that's not really a car, it's a van, but hey, who cares? And then we're going to say BMW, oops, BMW. And then we're going to say, I know we're mixing makes and everything. Who cares? We're just gonna, let's say for instead of BMW, let's just say a Nero. And one last one. Anybody got a good name here? Let's say a Yugo. There's a one from before everybody was probably born. Yeah, it's, the Yugo. It was pretty bad. But anyway, we're going to have this list of cars, and we're going to iterate over each one. So for car in cars, remember we did this in the past when we're doing loops. So for car in cars, we're just going to print out our car and see how that does. But because we have other code here, let's go ahead and clear out that. And let's go ahead and also clear out a lot of the stuff down here so we don't get any messes. So let's just comment it all out. Okay, so now let's see what happens here. As you expect, it goes through this. So remember, this is our loop variable car, and what it does is it takes this list, this container object, this iterable object, and it goes through it item by item. And each time it goes through the loop, it assigns the item to, or the element to car. It binds it to car. So the first time through, it's going to bind Prius to car, then Odyssey to car, then Nero to car, then Yugo to car. So the first time it goes through here, it's going to take element 0 and it's going to make that to car. So if we try to print car, it's going to print out Prius. So then when we get to the end of this, we're going to go back up and it's going to say, okay, now we're going to bind the second one, which is Odyssey, to car. And then we're going to print out car, which is Odyssey. And then we loop up again and we rebind Nero to car. And the fourth time through, we're going to bind Yugo to car. So every single one of these gets bound to it and it prints it. So that's how our basic for loop is going to work. So let's go ahead and comment that out. There's something else you need to worry about, and that is going out of range. So if you go out of range, bad things will happen. Just keep that in mind. So here we have a list, 1, 2, 3, 4, 5. I'm going to say I in the range of, well, we don't specify the original, so it's going to make it to whatever we have here. So I've made it to the length of my list plus 1. And what I will do is I will print my list at that place. And you can probably see we're going to have a problem here. So if I hit play, boom, it's going to go through it. It's going to do 1, 2, 3, 4, 5 because we have the 1, 2, 3, 4, 5 elements. But then because we go one beyond it, it's going to go to the 6th element. What's going to happen? Kaboom, it's going to say index error. The list index is out of range. This is something you'll see during your career quite a number of times. It just means that what we've done here is we've tried to do something, because if you look, it's going to tell you what line number, line 14. 14, we're trying to print something beyond the range of our well, the index is beyond the range of the actual list. So it's going to give us an error. So we don't like that kind of thing. So we'll try to avoid that. So if we were to change this back to just there, you'll see that it should print just fine, 1, 2, 3, 4, 5. So we can also do something rather cool, which is, we've mentioned this before as well. You can use the enumerate function, and enumerate is, it does something really nice. It gives you not just the value in the list, but it also gives you the index, because sometimes when you're going through things, you need to know what the index is. So if we say for index and value in enumerate of my list, it's going to return both the index and the value here, and you can use those. So when we go and look at it, sure enough, the 0th position, which the 0th index is equal to 1, the 1th is equal to 2, and it goes on and on like that. So that's pretty easy to understand. We've talked about the enumerate function before, so this shouldn't be a surprise to you. So now we're going to look at built-in functions that support lists. Again, we have a lot of things here. It's just nice to know that you have all this functionality out there if you need it. So let's go ahead and take a look at some of this. So we're going to start with the all. Let me see here. We'll just start with the all command, or the all function. So all given a list returns true if every element in the list is true. And that means that it's not equal to 0 or false or if empty. So if we say print all of my list, so my list was 1, 2, 3, 4, 5 up there. So when we look at it, are all of them non-zero and non-false? That should be a true. So then I'm going to look at, I'm going to make empty list, which is empty, and then I'm going to print all of empty list and see what it gives us. So when we run that, we're going to get true, because every single one of those are true. And then when I go ahead and set it to an empty list, that also evaluates to true. So keep that in mind, that an empty list is also all, well, it returns true, because everything in there is essentially 1 or true. So then we're going to go down here, we're going to redefine empty list, and we're going to do a print of it. And then what I want to show you is that if we put in false for 0, I want to show that all of empty list comes out to the same thing. So essentially what we've done here is we're printing out the list. Then we're saying empty list is equal to list. We're just setting it to nothingness. Then we're going to print out all of it, and it should return true, which it does over here. And then we say empty list is 0, 1, 2, 3. And then we're going to print all of it, and it should come out to false because we've got a 0 there, and sure enough, it's false. And then we're going to change that to the 0th element to false, and again, it should be false. And when we do that, of course, it says false, false. If we were to change element 0 to, let's say, true, what would happen here? What do you think would happen? Dun, 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 it's true, because that 0 was the thing that held it up from all evaluating to it, because 1, 2, 3, those are true-ish values. So yeah, so that's how all works. I don't have a good example off the top of my head why you would want to do that, but just know that you can. So let's see, let's go to any. Any is kind of interesting. So all basically says, are each element non-zero, non-false? And any says, are any of them non-zero or non-false? So if we go over here and we say, oh, we're going to have to go and give us empty list again. Hold on, let me see here. So empty list, let's go ahead and uncomment that. So we're going to say any of empty list. So any, this one wouldn't satisfy it, but 1, 2, or 3 means that we're going to get a true back on here. So if we run it, sure enough, we get true. So that holds just as we think. Then max. Max is a nice convenient function. It saves you the work of going through and doing all kinds of mathematical functions with if, else, and stuff like that. So we can say here that the 0th element is going to be -1. So we're going to have -1, 1, 2, 3. Then we're going to print that out just to verify that. Then we're going to ask it for the max. And the max in there should obviously be 3, but let's see what happens. Boom, yep. So we print out our list, and then sure enough, the max is 3. So max acts as you expect. It gets you the max value in there. Then min, if you can believe it or not, does the same thing, but the opposite. So it's looking for the minimum value that you have in that entire list. So if we're looking, we know it's going to be -1. Let's go ahead and put play. And sure enough, the min is going to be -1 at that point. And another neat function, we have sum. We can actually do a summation of everything in that list. So we can take the list of -1, 1, 2, 3, and we can sum that up. So if we hit play, oops, we get a type error. What did I do wrong here? So, oh yeah, I know. I had this is something I wanted to do earlier. So if we put in like a value there, it just gives us, actually, it's still giving us an error. So let's go back and see. So this is a good chance to show you error checking. So we look up here, we see that it's in line 49. So you know that this is where we're offending. And the reason we're offending is this is 3, which is a string. If we put 3 as a number, then it can do a summation, and it will do a summation. So it'll add up everything there. But if we have anything like so the reason I had that example in there was to show that the items in there have to be integers. So, or floats, I imagine. So if we were to do this and we were to say, like the first element is 1, then they're all still integers. Like, -1, 1, 2, 3, but we're going to replace the 0th, which is -1 with a 1. So we're going to get 1, 2, then 4, then 7. So we'll get a total of 7 there. So the sum of 7, the sum of everything would give us the 7 here. But what I wanted to do is show that they have to be the same type. So if I put in Christmas here and try that, it's going to give us a type error. So the unsupported operand types, because it's trying to add integer to string. So you'd expect this. So just be careful when you're doing that you're always going to have something in there. And let's go ahead and see what happens when we mix integers with floating points. So if we do that, you're going to see that it's converting the summation to a floating point. So that's a nice thing to know in the future. So anyways, you can always, if you wanted to, you could always cast that back to an integer this way. So you could go in here and do that, and boom, it's going to give you 7 instead of the 7.0 that we saw before. So that is essentially a bunch of the functions that we can use when we're iterating over a list or whatever. So this, again, it's pretty straightforward, a lot like what we've learned before. If you have any questions, feel free to ask, reach out, and I can give you a tour in Zoom. So just let me know. Otherwise, I will see you in the next lesson.